Hey guys, welcome back to my channel, and today we're going to learn about how can we find the trailing numbers of a number. Sorry, trailing zeros of a number. Okay, so first of all, what is trailing zeros? We need to know about that. Okay, so trailing zeros is nothing but suppose we are given a number and the value is 6. So first of all, to find the trailing zeros you need to find the factorial. Okay, you need to find the factorial of that particular number first, and then you have to find how many zeros are present in that particular number. Suppose the factorial of, this is how you write the notation of factorial in mathematics. So factorial of 6 is 720. If you haven't watched my how to find the factorial video, you can check the video. I will provide it in the links, the video link in the description. Okay, so for now, the factor first you have to find the factorial of a number. So factorial of 6 is 720. So how many zeros are there? We can see there is only one zero. Okay, so the output should give only 10. Okay, so trailing zeros is 1. So I hope you got the concept of trailing zeros. So let's proceed to write the code for it. Okay, so yeah, first I'm going to include the header file of the C++ code, and so namespace std. Okay, now we'll define the driver code, that is the main, which is important to execute the code. We'll define a number and simply input it. Okay, now I have a very good habit of breaking code into pieces, so I'll break this code into two. That is, one is the driver code. This is the driver code mentioned here, driver code, and this will be our main function to this will be our important function to find the trailing zeros. So let me define this as trail zeros. Okay, and define a variable and inside it, and then yeah, now I'll write this for loop. This code is to find the factorial of a number. Again, I'm saying, if you don't know how to find the factorial of a number, you can check the video I'll provide in the description. Okay, the link I'll provide, and then you can check how to find the factorial of a number. Okay, so I'm not going to explain this here. Okay, so this is how we can find the factorial of a number. Okay, okay, sorry, we'll store this to, let's give it multiplier equals multiplier times I. I'll just define here int, this will just copy this, yeah, equals to 1. And yeah, we are done till here. Now we have found the factorial of a number. Okay, any number which will provide during the execution of the code. Okay, now what I'll do is I'll check if I'll count the number of zeros this particular factorial has. Okay, so uh, while multiplier is while multiplier percent 10. Okay, while multiplier plus percent 10 is equal to 0, what we need to do is we'll simply increment our counter variable. Okay, and we'll return counter. Now you should make a very good habit before writing any program. You should first write the variable and then declare it. later. Okay, so this is a very good practice, or rather you can say approach. So let me explain what I did here. Okay, see, till here you need to know how to find the factorial of a number, and from here what we do is, suppose we got the factorial as in case of 6. Suppose we input here 6. Okay, so we know that factorial of 6 is 720. So why I did percent 10 here, because this stores the factorial of the number n. Okay, so this has stored the factorial of the number, and suppose it got 720 here. Yeah, this will give 720 if we input 6. So each and every time while, why I did while here, because we don't know how many times we have to run the loop. Like for loop we know that we have to run till n. Okay, whatever we'll provide. So in this case we have provided 6, but in this case we don't know how many times the loop will run. That's why we have given while. And while this 720 percent 10, since it is divisible by 10. Now why we did divisible by 10? Because we need to find the number of zeros, right? So in order to find the number of zeros, we have to uh, get the remainder of the last digit. I mean you have to get the remainder as 0, right? So it should be divisible by 10 or it won't work. So after this I'll just write multiplier equals to so I'll just copy paste this here, divide by 10. Now why I did divide by 10? Because each and every time, suppose in the first while in the first iteration, right, it divides by 10. So what do we get? 10 divided by 720 gives us 7 10 7 70, and this will be 20, right? So 72, simple. Then we'll get the remainder as 0, so it is divisible. Okay, so we we got this. Okay, now why I did divide by 10 here? Because each and every time, suppose I divide by 10, okay, here, so I got 72, right? So we need to check how many zeros. Okay, so 10 I got already, so this counter variable will iterate once. So from 0 it will get the value as 1 here. Okay, so again when I divide, multiply equals to multiply by 10, it will give us result as 72 here, because we need the remainder quotient here. Okay, see here quotient is 72. So again now the value of multiplier is 72. So again it goes here and it checks whether 72, the second part. Okay, second iteration value is 72. Now it checks whether 72 is divisible by 10 or not. So we know that 72 is not divisible by 10, because to in order for a number to become divisible by 10, the last digit should have 0. So here it doesn't have 0. Okay, so this will immediately come out of the loop and the value of counter is still 1. So we know that in 720, I mean in the fact in the trailing zeros, I mean the number of the 6. Okay, the number is 6, so trailing zeros in case of number 6, after finding the factorial, number of times 0 occurs is 1 here. Okay, so I've just commented this part because in order to explain you with one example, in this case I've taken 6, so 1 is the number of times trailing zeros will be there. Okay, so let me just call this function. Now this function will return 1 here in this in here. Okay, in this function. Now I need to call this in the main driver. Okay, so I'll just name it as, say, uh, z. Okay, and give fact, and now I'll just display it in the terminal. The number of zeros trailing zeros in which number? The number we have input here is what? Is nothing but the return value from this function trail zeros. So we have taken the value of this the return value which returns counter to this function as, oh, this is not fact, sorry, this is trail zeros, right? So yeah, done. Now this will store the answer to this. So the number of trailing zeros in the input number, that is n, is the return value of this function trail zeros. Okay, is I'll just give z. We can directly write trail zeros here. Okay, no problem. This is just the alternative way. Okay, so we are done here, and let's save this as trail 1. Now let's try to run this. Yeah, now let's input 6. See, the number of trailing zeros is 6. Similarly, I'll just try to input 5. Okay, let's try to input 5. It should give me, I think it should give me 120. It should also give me 1 because the factorial of 5 is 120. So let's give 5 here. Yeah, still 1. So now let's try to give another any number, like say 10 is 2. Okay, let's check the factorial of 2. Okay, let's check the factorial of 2. Let's try to run factorial of not 2, 10. Okay, so see, factorial of 10 is double zeros. Okay, 2 is the right answer. Check. Yeah, 2 is correct. Okay, okay. But guys, there's one problem here. Okay, let me explain you what is the problem. Uh, Suppose if you give a little large number, then this program will fail to, like, it is not optimized. It is a naive solution. Okay, just let me write here. It is a naive approach or solution. Okay, so I'm going to teach you two methods. Okay, this is one simple naive solution, but just let me try to uh, run again, and here let me input suppose 16. Okay, now it's giving 0. Okay, now why it's giving 0? It should have given me something else. Okay, just let me, where's the, okay, I'll just write this as 16. No, 16 factorial, right? 16 factorial of 16. Just let me write here 16 here. It should give me something else, not 0. So I'll tell you why it's naive. I think it's here. Let's give it 16. Sorry, yeah, 16. Okay, so this is some huge value, right? So it's including exponential, something like that. So it should not give me 0, right? So this is a naive approach. It will just give you a buffer overflow. Okay, so in order to fix this problem, we have a different approach. So now let me teach you the different approach. Okay, let me erase all these things here. Now, why I taught you the naive solution first? Because we needed to understand what trailing zeros, what do I mean by trailing zeros, right? So that's done. Now let's try to optimize the code. Okay, so see, suppose there's a number 1 times 2, then 3, then 4, then 5, then dot 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 dot, dot 10, and then again there will be like 15, then dot 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 dot, something like that. Okay, then 20. Okay, so what we are going to do here is we are simply going to optimize it. Okay, so suppose you take 5 as a number, first number. Okay, so we know that 5 has one prime factor as 5. There's 5 into 1, there's only one 5. Okay, and in 10 we have 2 into 5, 2 into 5, and then here we have 3 into 5, right? And again in 20 we have 5 into 4. Sorry, 20 is like that, right? I'll just write it like this: 20, and the prime factorization is 5 times, then 2, then 2. So this is 5 into 2 into 2. Okay, so there are two 2's and one 5. Okay, so what we can see common here is here we are having 1 1 1 1 5's. Okay, right? So there are 1 1 5's, but there are more number of 2's than 5. Okay, so there is one exception also here. Okay, so the exception is that if you go till 20, after 20, if you go till say 25, right? If you go till 25, now see there is 5 into 5, right? There are two prime factors, oh, that is two fives, right? So there is no point considering these 5, then 10, then 15, right? We can go directly from 5 to 25, and then next jump it will be go till 125, right? So each and every time, like it's 5 into 5 into 5 in 5. Okay, so this is 125 here. Okay, so uh, the fives here are okay, so this so see here there is only one 5, right? So till from 5 to 20 there are only one fives. Okay, one fives, one fives. Okay, and again, but when we reach 25 we get two fives. Then again if you go 25 again till 30, you get, again you'll get one 5 into 6, and the 6 will have 2 into 3, right? So it is really, very tedious method. Okay, so again here is 1 5. So how will you handle this problem? We'll only consider those which have, you know at max, two fives and at least one fives. Okay, so just let me erase this part here. Yeah, so max will have two fives, right? And minimum will have uh this is 2, minimum 1 5. Okay, so since you are starting from 5, so we'll just consider 5, then 25, then again next 125, and so on. Okay, so how will you frame the formula for this? Okay, so we have to move 5 times, again 5 times, again 5 times. So we'll just put a for loop here. Okay, that will iterate every 5 times. Okay, so how will you frame this? First let's include the library. Okay, so using namespace std, just create a main function. Sorry. Okay, and now just say n, then cin, and then yeah, So I'll just write this part later. So everyone has different approach. This is my approach. Okay, so int trail, this will be O for optimized. Okay, so let me write here this int n. Okay, now what I'll do is I'll run a for loop from 5. This time I'll run from 5. Okay, because we are starting from 5, right? We don't need the other numbers. Yeah, see, we're starting from 5, right? Where is it? Yeah, we are starting from 5 to optimize the code, right? Because we need, there is an exception of 25 that there are two fives, right? Again, if you go to 30, you'll get 1 5 as a prime factor, right? Prime factor, okay? But see, this is the main part, okay? You have to see. This is the main part, maximum and minimum, okay? So two fives and maximum two fives and minimum 1 5. So minimum is 1 5, so we'll start from 5, right? So yeah, now what we'll do is we'll go till the number which we have provided, sorry, and we'll just, instead of incrementing it, we'll just give I is equal to I times 5, because we're I said earlier, right? 5 5 5, we just have to follow this path. 5 here, 5 5 5. Okay, so first iteration, it will check for 5. Second, 5 times 5 is 25. Third, 25 times 5 is 125, and so on. Okay, so here this part is done, and now what we need to do is we'll just res. I'll just define value res. Okay, let me define it here. Int res equals to 0. Okay, so what trying to do here, you'll just know right now. Okay, so what I did here is, every time I get suppose now value of res is 0, so 0 plus n by I. Now why n by I? Because, sorry, because whatever we input n, okay, suppose I gave an input n as 5, right here. Okay, so first let's try to run this code. Okay, I forgot to call this. Okay, sorry. I'll just simply see out it here. I'll just copy this from here. Okay, mm, is trail o and okay, yeah, it's done here. Okay, now let's try to run this. Okay, it's not working. I don't know why. Let me check this. Okay, and okay, just call this. Okay, fine. I think run. Let's see out here. Run. Sorry, guys. Okay, something is there. Let's save this. Yeah, 5. Okay, it's not taking input. I don't know why. It's crashing or something. Just let me open the compiler, online compiler. Okay, okay, let's run this. It's not taking input. Okay, let me just take this as C. I don't know what's the problem here. Int C goes to this. Now let's try to run this. Okay, I haven't given numlock. Okay, that's the reason. Trailing zeros in 5 is 25. That is wrong. Okay, I forgot to give this thing, right? Forgot to give this part. Sorry. This part. Okay, it's still here. No, till here, right? It's only this part. Okay. I don't think we require this part. This would be enough. There is some problem here. Okay, just took the value and 6. Okay. Mm, I think we need to find the factorial first, right? That's the problem. Okay. 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 Let's find the factorial first. Just let me paste that part. Now let instead of giving this, let me give multiplier, and then here as well multiplier. Now this should return me something, that is return res, right? 28 is even greater. Okay, 5 has how many trailing zeros? 1, right? Okay, we can give. Why am I doing this? We can directly return. No, I forgot to return the value. Yeah, this should work. Okay, I haven't defined res. Okay, no problem. Equals to 0. Now this should work. 5, 28. 5 has, okay, 5 is less than equal to 5. So yeah, now it's getting the answer, right? 6 is 1, and run again. 5. Yeah, now it's working, right? So you can see, let me cancel all this. So here, while we give input as 6, it should give me 1, because number of trailing zeros of 6 is 1. Okay, now what we were going to do is 16, right? Let's check for 16 as well. Let's see if it is working. Yes, now it's giving us the correct output. So I hope you understood what I'm trying to say, right? Sorry guys, I just took a little bit time because I just pretty much messed up a bit in the beginning because it was simply to return the result value, right? I was doing something which was unnecessary. So yeah, here we are done. So again, I'll just wrap up everything, okay, in brief. So whatever we did here was this was a naive approach, okay. So what do we mean by naive approach? We just simply find the factorial, okay. As I told you, to find the trailing zeros we have to simply find the factorial first of the number, and then check whether it's multiple of, I mean, divisible by 10 or not. If it is, then just keep on counting the number of zeros at the end, okay, and then divide each time the iteration happens, so that we'll get the last. We just need the last digit, okay. We just have to check. So here, last digit, if it is again, so again it will iterate, so it will give 2, but in this case it won't give 2 because 720 is the factorial of 6, and once second time it will give it 72. So this, if you run, it will give you something else, okay. In this case, when I give a huge value 16, it gives me 0, which is totally wrong. So this is not an optimized way of doing it, and in this case which I have shown you, this is really simple and a small piece of code. So I have taught you everything, like whatever has happened here, it's little pretty much messed up. So you can ask me whatever doubt if you have any doubt in the comment section. So this is the most efficient way, okay. This is the most efficient way, okay, efficient approach. I think, yeah, that's done here. So thank you guys. If you have any problem, just or any doubt understanding this concept, you can ask me in the comment section below. So for the time being, I'll just take a leave. Thank you.